Welcome to Across the Globe. Today we will learn about exception handling in Python. Exception handling is a crucial programming concept that enables developers to manage errors that might arise during program execution. By implementing exception handling, programmers can address unexpected issues and prevent program crashes. This ensures that the program can gracefully handle exceptions and continue executing without disruption. For instance, imagine a banking application where a network error occurs when a user is trying to make a transaction. By incorporating exception handling, the application can display a user-friendly message informing the user about the issue and prompting them to try again later, thereby enhancing user experience and application resilience. Python provides several built-in exception classes like ValueError, TypeError, and IndexError to handle specific types of errors in code. These exceptions help in identifying and responding to errors effectively. In addition to the built-in exceptions, Python allows you to define custom exception classes by inheriting from the base exception class. This capability enables developers to create specific exception types tailored to their application's requirements. For instance, one might create a custom exception class named FileNotFoundError to handle issues related to missing files in a file processing application. By leveraging custom exceptions, developers can enhance the clarity and accuracy of error handling mechanisms in their Python programs. In Python, try-except blocks handle exceptions. Within the try block, operations that could produce exceptions are enclosed. The except block following the try block contains the code to manage specific exceptions caught. The exception type is mentioned in the except block to specify which type of exception to capture. For instance, consider a scenario where a list contains 3 elements, and an attempt is made to access the 4th element, which doesn't exist. By placing the code inside a try block and catching the index error in the except block, the program can gracefully handle the out-of-range access by displaying a custom message like index out of range. When handling exceptions in Python, you can manage multiple exceptions by either utilizing several except blocks, with each handling a distinct exception type, or by employing a single except block with a tuple containing the various exception types. For instance, if you wish to catch a zero division error specifically, and any other exceptions generally, you can structure your code like this. Python try x equals 10/0 except zero division error. Print cannot divide by 0 except exception as e. Print an error occurred e. In this scenario, the first except block caters to the zero division error, printing a message specifically for that situation. The second except block, which handles the exception base class, serves as a catch-all for any other exceptions not explicitly declared. By having this dual-layered exception handling, you can precisely manage distinct error types while maintaining a safety net for unexpected exceptions that may arise during program execution. A finally block is used in Python for defining cleanup operations that should always be executed, regardless of whether an exception occurs or not. In the provided example, a try block attempts to open and read a file. If a FileNotFoundError exception occurs, a message is printed. The finally block ensures that the file is closed, regardless of whether an exception was raised or not. This is crucial for releasing resources and preventing memory leaks. Raising exceptions manually in Python involves using the raise keyword followed by an exception class instance. This technique is employed to indicate errors or exceptional circumstances in a codebase. For instance, if a program mandates positive numbers and a negative number is entered, a value error exception can be manually raised with an informative message like number must be greater than 0. This process aids in enhancing code readability and error handling. Handling exceptions in Python is like preparing for unexpected roadblocks during a trip. Just like keeping a spare tire in your car in case of a flat, we use try-except blocks to anticipate and address potential errors in our code. If an exception occurs, like a flat tire, our program can gracefully handle the issue without crashing. By using try-except blocks, we can navigate around obstacles and ensure our program continues running smoothly. Hey, code conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. In the given Python code snippet, we have a function named driveTrip, which symbolizes a journey. The concept of exception handling in Python is illustrated through an analogy of preparing for unforeseen obstacles during a road trip. Initially, the trip is initiated with the message, "Starting the trip." Following this, a simulated driving scenario is introduced, where a potential issue is encountered, represented by the code raising an exception with the message, "Flat tire," symbolizing an unexpected roadblock in our journey. The try-except block is implemented to manage any exceptions that arise during the trip. In this scenario, when an exception is caught, the code gracefully handles the situation by displaying the encountered issue and addressing it with appropriate actions, such as calling for roadside assistance or fixing the tire. The finally block ensures the execution of code, irrespective of whether an exception is triggered, symbolizing the continuation of our journey despite the challenges faced. By employing exception handling in Python, we equip our code to anticipate and resolve unexpected errors, ensuring a robust and uninterrupted execution flow. Akin to successfully navigating through unforeseen obstacles during a real-world road trip, exception handling in Python is a crucial aspect of industrial applications to ensure robustness and fault tolerance. Let's consider two real-world examples where exception handling plays a vital role. 1. Web scraping application. In a web scraping application, unexpected issues like network errors, website structure changes, or data format inconsistencies can cause the program to crash. By implementing exception handling, the application can gracefully handle these issues, log relevant information, and continue scraping without losing important data. 2. Database operations. When working with databases in an industrial setting, exceptions such as connection errors, query failures, or data integrity issues can occur. Exception handling allows developers to catch and manage these errors, enabling the application to recover from transient issues, roll back transactions if necessary, and provide meaningful feedback to users or system administrators. Exception handling in these scenarios not only prevents abrupt program terminations, but also enhances the overall reliability and maintainability of the industrial applications. Across the globe, keep learning, stay curious, and I'll catch you in the next video.